All right, got another one for you. These are called mixture problems, right? So it says a refinery has 7,250 liters of gasoline methanol blend that's 6% methanol. How much pure methanol must be added so that the resulting blend is 10% methanol? All right. So, mixture problems. Now, when I think about mixture problems, here's what I think about right here. I think that if you've all, hopefully, if you hadn't done it yet, you'll do it sometime in your life. But at some point in your life, you will need some rubbing alcohol, right? It's called isopropyl alcohol. This is the way I've always remembered this, right? It's not crazy. It's not a formula if you can just pull it up. I mean, it might be a formula, but it's not a problem. Most people are like, I can't remember formulas in math. There's too many formulas. So let's think about this for a second. So let's think about the alcohol, right? Isopropyl alcohol, also known as rubbing alcohol, right? And I go to the store and I buy a 10 ounce bottle. That's how I think they're about 10 ounce bottles of them, right? And on the bottle it says 70% alcohol. So it's a 10 ounce bottle that's 70% alcohol, 70% isopropyl alcohol. So here's the question. How much pure alcohol is in there? It's 10 ounces and it's 70% alcohol. So how much actual alcohol is there in there? Also known as the pure amount. Most people are going to say, 7 ounces. Right? So this is how I remember this, right? So let's think about this. 10 ounces, that's the quantity you have. Quantity. Or also known as the amount, right? Whatever, that's the amount you have. And then this is the, percent strength. Strength. That's the strength of it, And then you have the pure amount. And if I multiply these two together, I'm going to get the pure amount. And this is a mixture problem. This is mixture. This is the little formula for mixture that I always consider. And anytime I'm doing a mixture problem, like the one above, I'm using this formula. Why? Well, because it makes sense to me, because I don't have to memorize it, because I can think about rubbing alcohol. The only thing I have to do is say, what about that rubbing alcohol? And then I can make perfect sense of it every time. So maybe that's helpful for you. There might be something else that might be, your preferred. Maybe you don't prefer rubbing alcohol. Well, it's easy to, so you might should. All right, so let's think about this. Refinery has gasoline methanol blend. So first, I can see that we're talking about a mixture. Mixture. So right out the gate, I'm saying, okay, amount times percent equals my pure, right? Because I'm thinking about my isopropyl alcohol. Then I make myself a table. All right. So a refinery has 7,250 liters of gasoline methanol blend that's 6% methanol. How much pure methanol must be added so that the resulting blend is 10%? So anytime I'm doing these, notice although you only see 2 percentages up here, there's actually 3 percentages because it says pure, right? How much pure methanol must be added? And what do you think the percentage of pure methanol is? Well, if it's pure, then it's 100%, right? So usually there's 2 things you're mixing together, or at least 2 things, you could have more, to get a third thing that you want, right? So you're mixing 2 substances together to get a third, and this is what this is what you want. So I always put what you want. This is what I want. I put that at the very bottom. Now, you don't have to do that. So let's get back into this, right? What do we want? Well, we want it to result in a 10% blend. So I'm going to convert this, I don't want to read percentages. I'm just convert it to a decimal. So that's what we want. Well, what do we have, right? These two things are what we have. Well, we have 0.06. We have that. And then we have pure. Well, pure is 100%. And as a decimal, that's just 1. All right, you can say 1.00 if you want, but I'm going to just say 1. All right. So now I know amount times percent is equal to pure. So let's see what else I got. The amounts. A refinery has 7,250 liters of gasoline methanol blend. So I know this is 7,250, right? It says how much pure methanol, so how much pure methanol must be added to get the resulting blend, right? The resulting blend is the blend that we want it to be. Like that's what we're trying to have in the end. So how much pure methanol? Well, I don't know how much. So I'm going to put a X because I don't know. Now, when I add those two, when I mix those two, the 6% and the pure, I want that 10%, right? How much am I going to have? Well, I know I'm going to have all of my 6%, and then however much I pour in there of the pure, I'm going to have that. So how much amount of the 10%? I'm going to have 7,250 plus X. All right. So now we know that the amount times the percentage gives me the pure amount. Well, this is going to be 0.06 times 7,250. And then this is going to be 1x, right? Or just x. And then this one's going to be 0.10 times 7,250 plus x. We're going to be multiplying. All right. And now let's think about my equation. Now, with mixture problems, the equation is usually pretty straightforward. Why? Well, because I know I'm going to be adding two mixtures together to equal a third mixture, or I guess a third, substance. So I'm going to do just that. I know I'm going to be adding the 6% with the pure, and I want to get a 10%. So if I say the 6% amount I have is 0.06 times 7,250 plus, right? And I should say pure amount so you know what's going down. We're talking about an amount here. Plus X. That's going to equal 0.10 times 7,250 plus X. And now we have an equation. The goal here is to make an equation that we can solve. So 0.06 times 7,250. 0.06 times 7,250 gives me, this is 435 plus X equals, I don't know why I did that one. Of course, that's 725, right? I'm taking this and I'm multiplying it here and then times there, so plus 0.10x. All right, I want to get my x's together and my other terms together, so I'm going to subtract this 0.10x minus 0.10x, subtract this 435 minus 435. That's going to equal, over here I got 0.90x, and then, 725 minus 435 gives you 290. We divide both sides by 0.90, and we got x equals, divided by 0.90, and we got x equals, All right, we got x equals 322.222, repeating. All right, so what does this mean? Well, if we got 7,250 liters of the 6%, and we're trying to convert it to a 10%, we're gonna need 322.22 repeating. I just 22 repeating liters of pure. Right, of pure, methane, methanol, and that's what we need to add to end up with that 6%. I mean that 10%. All right, it's important to tell yourself, what's going on here. So, hopefully you found that part helpful. We'll do another one. And when we do another one, you should consider pausing the video and see if you can do it yourself. But let me give you the question first. All right. It says, if 2 liters of a 10% vinegar solution is mixed with X liters of a 30% solution, the result is a 25% vinegar solution. How many liters of the 30% solution were mixed? All right, so I'm going to bring this question into the table. So first, I know we're talking about a mixture. So I'm saying the amount times the percent equals the pure. And we're talking about the pure amount. All right. Here we're mixing 2 things together to get a third. The third I'm going to say is what I need. This is what I'm looking for, and these are what I have. All right, that's how I'm going to set it up every time. So let's go back to the question. Once again, the question says, if 2 liters of a 10% vinegar solution is mixed with X liters of a 30% vinegar solution, the result is a 25% vinegar solution. How many liters of the 30% vinegar solution were mixed? Okay, so I'm going to go through that again, but now I'm going to start pulling information out of it. So, if 2 liters of a 10% solution is mixed with X liters of 30% solution, the result is a 25% solution. So the result, right? The result, maybe I shouldn't just say need. This is the result, right? And the other things, depending on the question, sometimes it says, we want to get this. But in this question, it doesn't say want, it just says the result. So result, right? And the result is a 25% solution, so 25.25. Now, what do we have? Well, we have a 10% solution, 0.10, and we also have a 35% solution, or 30% solution. So if 2 liters of a 10% vinegar solution, so we have 2 liters, is mixed with X liters of 30% vinegar solution. So I don't know how much we have here, but it's X liters. The result is 25% vinegar solution. All right. Well, the result, when you mix those two up, right, we're mixing. Maybe I should be saying mixing instead of have. This is what we're mixing. And then we want the result here. So if I mix those 2 things together, I'm going to have 2 plus X. Right? Now we can get our pure amounts. And we're just doing, we're just multiplying amount times percentage equals pure amount. So that's 0.110 times 2. This is 0.30 times X. This is 0.25 times 2 plus X. All right? When I'm mixing 2, chemicals together and getting a resultant chemical, I know I'm taking the 2 chemicals I'm mixing and I'm adding them together. So 0.10 times 2 plus 30 times x is equal to 0.25 times 2 plus x, right? Now I'm just, 0.10 times 2, 0.10 0.10 times 2 is 0.2. Not doing good with this. I should have got that one without even trying. I'll do that one. 0.30x equals, all right, 25% of 2 would be 0.5. Boom. Quick math. Plus 0.25x. So we just distribute that. Now we're just getting our x's together. So minus 0.25x minus 0.25x. And you have, 0.05x equals, I need to take this 0.2 and subtract 0.2. Subtract 0.2, so that equals 0.3, right? Some people are like, why'd you create the decimals? You could have left it as percent. I could have left it up here as percentages, and it would have been fine, but I just prefer to change it to decimals because when I see percentages, I just change them to decimals to deal with them. It's a safe move. So all right, I'm trying to get x by itself, so I divide by 0.05, and x equals, I'm thinking 6. 0.3 divided by 0.05 is equal to 6, yep. So, what is 6? 6 is we need 6 liters of 30% to mix with 2 liters of 10% to get, which if I mix those up, right, how much am I going to have? I'm going to have 8 liters of 25%. All right, so 6, the question was, how many liters of 30% solution were mixed? The answer is 6 liters. 6 liters. Hopefully you find that helpful. All right, thank you.